Okay, this is Properties of Logarithms Part 2. So we're still using the same properties of logarithms. Remember, there was an addition property, there was a product property, there was a quotient property, and there was a power property. That's on the other video, and I'll be using those here. Now, these are more like puzzle problems, okay? But before we go on, let's remind ourselves of these properties, right? These rules. If I have any base and the argument is 1, then that log evaluates to 0. For example, if I have log base 5 of 1, then that's equal to 0. Right? So if you see this, log base 5 of 1, then that evaluates to 0. That's it. Right? If I have log base x of x, or so if these two numbers are the same, it evaluates to 1. So if I have log base 5 of 5, that equals 1. So all right, so here you'd be given 3 logarithmic values, and you're going to use those, some kind of combination of those, to evaluate these problems. Okay, and we're doing this without a calculator. Well, all right, so let's look at this. So we got here log base 8 of 6 is 0.9. What am I doing? So what I want to put here are these two rules that I just mentioned up here, right? Log base x of x is 1. That's what I'm doing here. Log base 8 of 8 is 1. And log base x of 1 is 0. So this would be log base 8 of 1 equals 0. It's a reminder of what that is. Okay, let's use that. So here. So what you're going to do is try to make 66 a combination of these numbers. So here I have 6 and 11. 66 is 6 times 11. So that's good. So I'm going to do that. So I'm going to rewrite this as log base 8 of 6 times 11. That's the first step. And now we're going to split that up. Log base 8 of 6 using the product property becomes log base 8 of 11. Okay, so that's it. Now, log base 8 of 6 over here is 0.9. And log base 8 of 11 is 1.2. So we're going to write 0.9 plus 1.2. That's going to give us 2.1. Right? That's it. That's what we're looking for. So this is the final answer. And this is all the work that goes into it. If you skip any parts of it, that's fine. Like most people will probably skip this step. Right? Most people will probably skip this step. So it's okay to go straight to this and then get these answers. All right. So let's do the next example. So log base 8 of 10 11ths. So here I have a 10 and 11. So this one's straightforward. I'm just going to rewrite it as log base 8 of 10 minus log base 8 of 11. So recall, if you have a fraction or a quotient, it splits up as a difference. Right? The top number first and the bottom number second. All right? And log base 8 of 10 is 1.1. And log base 8 of 11 is 1.2. Subtract those two, you get negative 0.1. And that's the answer to that one. All right, log base 8 of 36. Well, 36 is just 6 to the second power. 36 is 6 to the second power. So all we're going to do is rewrite that as log base 8 of 6 to the second power. Okay, now I'm going to bring down the exponent as a coefficient. So what's happened here is I took that exponent of 2 and brought it down as a coefficient. That's a power rule for logarithms. And log base 8 of 6 is 0.9. So it's going to be 2 times 0.9. So it's 1.8. There's the answer to that one. All right. Next example, log base 8 of 1 over 100. So 100 is 10 squared. So first, let's write it this way. Log base 8. Let's do the quotient rule first. So log base 8 of 1 minus log base 8 of 100. And we know log base 8 of 1 is 0. So we just write 0. Log base 8 of 100, that's log base 8 of 10 squared. Right, 100 is 10 squared. All right, so I'm going to go ahead and drop the 0. And there's still a negative sign there. We're at negative 2 log base 8 of 10. So I've taken the exponent of 2 and brought it forward as a coefficient. Now I got to do is log base 8 of 10, which is 1.1. It's going to be negative 2 times 1.1, which is negative 2.2. So I replaced the log base 8 of 10 with 1.1, and I got negative 2.2. All right, moving on. Log base 8 of 480. So you look on here, 480 is going to be 6 times 8 times 10. So let's do that, right? 6 times 8 times 10. So that's log base 8 of 6 times 8 times 10. Now, the order doesn't matter. Order doesn't matter. If you have it in a different order, that's fine. But the goal was to write it in terms of these, right? So it's pointless to do like 4 times 240, right? I want the numbers that I have here, 6, 8, and 10. All right. So log base, so I split this up using the product rule. So log base 8 of 6 plus log base 8 of 8 plus log base 8 of 10. Okay? And log base 8 of 6 is 0.9. Log base 8 of 8 is 1. Log base 8 of 10 is 1.1. Right? So that's the log base 8 of 6. 1 is log base 8 of 8. And 1.1 is log base 8 of 10. So this ends up being 2.13. Final value of 3. All right, that's it for those. Okay, so sometimes I will give you to you in a different form, where I give you letters, variables to represent these values instead of actual numbers, right? So there's less math involved, less arithmetic. All right, so as a reminder, log base 7 of 7 is still available, right? When you have log base 7 of 7, it's 1. If I have log base 7 of 1, is 0. So that's still a option, right? Those don't need letters. They don't need variables, right? All right, let's continue here. So 25 and 11. 25 can be written as a power of 5, and there's 11. So we'll write log base 7 of 5 squared over 11. Okay. Now we split that up. Right, use the quotient rule. So it's log base 7 of 5 squared minus log base 7 of 11. Okay, and that the exponent comes down. So it's going to be 2 log base 7 of 5 minus log base 7 of 11. Okay, so log base 7 of 5 is B. And log base 7 of 11 is C. So that's going to be simply 2B minus C. And that's the answer. All right, and then log base 7 of 21. So the next one. Well, 21 is 3 and 7, right? So the biggest mistake people make is they forget about the base, right? They are generally not included in these list of logs where they give you variables for, but they assume that they don't have to give it to you, okay? Because everybody knows that log base 7 of 7 is 1. So that's log base 7 of 7 times 3, right? 21 is 7 times 3, so we got 7 and 3. And I'm going to split this up into log base 7 of 7 plus log base 7 of 3. So I split that up as a sum. So I changed the product to a sum. And I wrote them separately. So log base 7 of 7 is 1. And log base 7 of 3 is A. So the answer is 1 plus A. And that's it. All right, next example. Log base 7 of 125. So 125 is 5 to the third. Right, so it's 5 to the third. Okay, so I have a 5 here, so we'll bring the 3 forward. So it'll be 3 log base 7 of 5. Well, log base 7 of 5 is B, so that's going to be 3B. And that's it. All right, let's go on to the next one. Log base 7 of 9 over 121. All right, so 9 can be written as 3 squared. Because log base 7 of 3 to the second power. 121 is 11 squared, and 11 is one of our numbers. So it's 11 squared. So I'm going to write that as using the quotient rule. Write it out separately. So I got that right? I wrote it as a quotient, so now it's a difference. Bring the 2 down, so it's 2 log base 7 of 3 minus 2 log base 7 of 11. Now we have these values. Log base 7 of 3 is A, and 11, is it 11? Yeah, 11 is C. So this becomes 2A minus 2C. I'm running out of space on my desk. All right, 2A minus 2C. All right, so this log 7 of 3 is just a direct substitution over here. All right, log base 7 of 3 is A. All right, last example. All right, log base 7 of 1 over 55. So that's same thing as log base 7 of 1 minus log base 7 of 55. Okay, and then log 7 of 1, that's 0. 55, I'm going to write that as log base 7 of 5 times 11. Now, this is where a lot of mistakes get made. Okay, this log base 7, now I know there's a product property where you split up as a plus sign, but there's a minus sign up here. So you end up doing log base 7 of 11 with a minus sign because I'm distributing that minus sign to whatever. Whenever I split this up, I'm distributing that minus sign. Okay, log base 7 of 5 is B, and log base 7 of 11 is C. Right, it's up here. 7 of 5 is B, 7 of 11 is C. So that's how I got negative B minus C. And that's it. Well, actually, let's do one more example. This is not on your notes. This is just a weird situation. Never mind. I'm going to stop because I forgot what the problem was. Okay. That's it. Good luck.